Okay, now let's move to part number 2 of our experiment. As mentioned earlier, this part is about verification of Ohm's law, and basically we will be measuring the resistance of a resistor using different methods and then using those measurements to verify the Ohm's law. The first part of this part number 2 is using multisim, and then we will be performing the same experiment using hardware also. So let's talk about multisim first. So in multisim, we will be finding the value of the resistance using 3 different methods. The first method is straightforward, where we will actually use the multimeter to measure the resistance of a resistor. So here you can see that this is a multimeter and we are operating it as an ohm meter because we have pressed the ohm meter button here in the multimeter. And the way we have connected this multimeter to the resistance is very important. It is important to note here that if you want to measure the resistance of a resistor, then that resistor should not be part of any circuit. It should not be connected with any other component besides the ground component. So this should be the configuration whenever you want to use the ohm meter in multimeter. So the reading of the ohm meter in this particular example is 100 ohms because we are using a 100 ohm resistor here. So this is the first method. The second method is using Ohm's law. What do I mean by using Ohm's law? I mean that we want to find the resistance of a particular resistor using Ohm's law. We know that Ohm's law, according to Ohm's law, V is equal to IR, where V is the voltage across a resistor, I is the current that is flowing through that resistor, and R is the value of that resistance itself. So if I manage to find the value of V and I for a particular resistor, I can simply divide V by I to find the resistance values. So this is the idea that we will be using in this way of measuring the resistance. So what we will do is, we will pick our resistor and connect it to a voltage source like this. So in this particular example, the voltage source is 10 volts. So the value of V is 10 volt. Now the remaining task is to find the current that is flowing through this resistor. And for that purpose, in multisim, we will be using ammeter or multimeter, whatever you want, to measure this current. Once you have the value of that current, you can perform V over I, V divided by I, to get the resistance value. And it should match with the resistor that you have selected, which is 100 ohms. Now, an important thing to note here is that this procedure is independent of the value of the voltage source. What do I mean by that? I mean that if you select a different voltage source, for example, if you select a 5 volt voltage source, then still you will get the same correct value of the resistance R. Why? Because the current and voltage are directly related. They are directly proportional to each other. If you reduce the value of V, the value of I will also reduce, and if you increase the value of V, the value of I will also increase. They are directly proportional, and the ratio of V and I never changes, which is in fact equal to the resistor. So with the help of the Ohm's law, we can find, or we can measure the value of any resistor. So this was the second way of measuring the resistance. Now the third way of measuring the resistance comes directly from the fact that the voltage and current are directly proportional to each other. As I have already mentioned that if you increase V, then I also increases, and if you decrease V, then I also decreases. And since they are directly proportional, it means when we will plot different values of V and against the corresponding value of I, we will get a straight line. And we can use that straight line to actually find the value of R. How can we do that? Let's see that on the next page. Okay, let's first focus on table number 4. In table number 4, we have several values of V, voltage, okay, and corresponding entries of I are also there. So let us focus on the left hand side of this table. On the left hand side of this table, we have workbench. Workbench simply refers to multisim. So what we have to do is, we have to select different values of the source voltage. Which source voltage? The source voltage in this figure, in this circuit. So first value of Vs, we have to select it equal to 0 volt. Then we have to select 2 volts and so on according to the table. And for each of these voltage values, we will have to measure the corresponding current that is flowing through the resistor. Again, let's go back to the circuit. So this is the current that we are going to measure for each different value of V. Once we have all of these values of the currents, we are ready to plot them on a graph. So here is a sample graph that is given in your lab manual, and it is also present in the file that will be shared with you. So we can use these values to make a plot. Okay. For simplicity, I would say that, okay, without assuming any values here, I would say that when I plot V and I from this table, I get this line. I'm just assuming, okay? So I get this line. We'll get a straight line, okay? Because V and I are directly proportional. So it will always be a straight line. Excuse me. So once we have the straight line, we know that its slope will be equal to R. Why? Because V is equal to IR according to the Ohm's law. V is equal to IR. So if I find the slope of this line, it should be equal to R. So this is the idea. The idea is to find the slope of this line, and that slope would be actually equal to R. Now how do I find the slope? Remember that on the y-axis we have V, and on the x-axis it is I. It is important that we that we fix the y-axis for V and we keep the x-axis for I. You can do it otherwise, but then you will have to be careful when you are measuring the slope. Okay, anyways, let's keep the y-axis for V and the x-axis for I. Now how do I measure the slope? I know that the slope is simply the ratio of the difference in V in the y-axis and the corresponding ratio. Excuse me, let me repeat this thing. So what I'm trying to say is that the resistance value should be the slope of this line, which can be calculated by finding the difference in the y-axis divided by the corresponding difference in the x-axis. So let us pick these points. Let me say that, okay, on the y-axis we consider this difference, which is from 5 volt to 8 volts, and the corresponding difference on the x-axis will be from 30 milliamperes to 50 milliamperes. So the difference in the x-axis is 50 minus 30 milliamperes, which is 20 milliamperes, and the difference in the y-axis is 8 minus 5, which is 3 volts. So these differences we can call them delta V and delta I. Let me write it here. Delta V divided by delta I, and in our setup here for the particular example that we have taken, it is equal to, what was delta V? It was 3 volts, and what was delta I? It was 30 milliamperes. So it will be 30 milliamperes. So for this particular line that we have selected here, if I find this ratio, that would be the value of the resistance. Okay, now please note that this is just an example, okay? So it's not necessarily the right line. You will get a different line, you may get a different line for the resistor that you will select. Okay, anyway, so these were the 3 different methods that we can use to find the value of the resistance. Now, the last thing that I would like to highlight here is table number 3. This table has 2 entries, one for the multisim and one for the hardware. Okay, so for the multisim, you have to fill in the value of the resistance that you will get from the ohm meter here, and the other values that you have to enter are the voltage value that you have selected. For example, you have selected 10 volts. You will write 10 volts here in this place, and the corresponding current that you will get from the ammeter. The ratio of those two values will be the resistance.